All right, hang on one second. All right, so the slide that says, so what is an exponent anyway? For the purposes of time, since we have like as a fast class, and let's just go up a little right there. So you'll see something that says, what was it, 3 to the 5, 3 to the 5th power? Like that. Can you guys see what I'm, ooh. Yes. Is that a little bit better? So
Yeah.
I think you see 3 to the 5. Can you guys see this okay?
Yeah.
Give me a thumbs up. Okay. So, you know, what it says, what is an exponent anyway? What I want you to think of, whenever you see an exponent, it's repeated multiplication. So I'm going to just write that down. So it's repeated multiplication. Instead of writing, in this case, 3, which is your base, 5 is your exponent. Instead of writing this 3 times 3 times 3 times 3 times 3, 2, 3, 4, 5. So instead of writing 3 5 times, we just have a shorthand notation for it. Okay, so it's 3 to the power 5. It's really 3 times 3 times 3. So this is 3 times 3 is 9, times 3 is 27. I'm running out of space. 27 times 3 is what? Can you guys help me out? Is that 81? Yes, no?
Yeah.
Yeah, and then 81 times 3 is what? 243. 243?
Yeah, I think.
260. Is that right?
No, 243.
243.
Okay. And, you know, for small numbers like this, we can, let me erase this. It's not too hard to write the numbers out. But, you know, when you have like a number like this, so we've kind of done these before, like 10 to the power 10. You know, when you start to have to go like 1, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. When you have to get really big numbers like this, it gets very difficult. Hang on one second. All right, so it gets very difficult to just write these numbers out. So we use exponents and we use bases. And one of the things that when we are doing math is we're going to start multiplying really big numbers together. So when we do that, it becomes much easier to develop a lot of rules to make the multiplication, the division, and a few other processes easier. So if we go to the next slide, we're not going to do this part just because it's too difficult to do through Zoom, but I'm just going to look at this. So if you go to the next slide that says, let me do a quick screen share because this slide's actually sort of important to show you. So if you look at this slide, this is just a lot of rules. And what I would rather spend today's class doing is just like, let's solve some problems. Let's make these, you know, a to the m times a to the n. Let's make this a more concrete set of examples by just doing some problems together. So I'm just going to discuss like one rule using that formula. Like, so they give you like, I think a to the m times a to the n, and that's going to be a to the m plus n. What I want to do, can you make sure you guys can see that? Let's just make this like a real thing. Let's do some examples. Let's like make it something that it's easy to understand. So like to start with, just a few notations. A is a real number. All right, it could be 2, it could be 10, it could be 15, it could even be X, and we will be doing this soon, it could be a variable, but it's a number, and it's also called the base. So this is your base, and this one up here, in this case, M or N, these are your exponents, and usually those are real numbers, and that's what we're starting with today. So like as an example, make sure you guys can see that. we can do like 2 to the 3, 2 to the third power. Sometimes we'd say 2 cubed. And if we wanted to multiply that by, say, 2 to the, say, 2 to the fourth power. Now, what we could do is we could say, so what this rule says is if you have two identical bases, so this is important, this is the same base as this. When the bases are the same, you add the exponents up. So this would be 3 plus 4. So 2 to the 3 plus 4 is just 2 to the 7th power. All right. So what these rules will allow us to do is instead of saying, okay, 2 times 2 is 4 times 2 is 8, instead of saying, okay, well, that's 8 times 2 to the 4, well, that's 16. And then like 8 times 16 is whatever that works out to be. Instead of like doing this step by step, we have like a quick rule to figure out what our final answer is. All right. Give me a thumbs up if that makes sense. Give me a thumbs up if that makes sense. Okay. So what I want to do is show you one. So this is an example that works. Now, what I want you to be careful about is like a separate example. Like, let's say I did let's keep the numbers easy. Let's say I do 2 squared. Make sure you guys can see that. Times 3 squared. All right. This does not equal. So this little means does not equal. All right. Very important. This does not equal 2 to the 2 plus 3, or more like 3 to the 2 plus, I'm sorry. I should have used different numbers there. It doesn't equal because this is not the same base. All right, so not the same base. All right, the bases have to be the same to apply these rules. Okay, so so different bases, you can't just like add the exponents. Okay, because like which base would you use, 2 or 3? So for this one, you'd actually have to go out. Sorry, I had to erase that. So if you were given a problem like this, and the problem said simplify, well, in this case, we don't have a rule for this yet. So you'd have to do 2 squared, which is 4, 3 squared, which is 9, and then multiply them together to get like 36. Okay. You could probably do a few other things, like I know 36 is like 6 squared, right? But like we can't apply this rule. All right, so that's the important part about these rules. Make sure you have the same base. As a second example, well, any questions on this one so far? Any questions?
No.
Now, another common thing to see, and I'll just write the rule here. So like I think I wrote it like, this might be number 2 on there. Yeah, so they made this number 2. So I think it was like a to the m.
We can't see
Like
the top of. We can't see the top of what you're
thank
writing.
you. So hang on one second. I'm gonna. So is it like pretty much like right here? You guys can't see above.
Yeah.
So like, sorry, you see this line? So can I write like right here? So like if I write. Can you guys see this part here?
Yeah.
Yeah.
Okay. I don't know if you see it, but I wrote a line here so I don't write above it. Okay, so you see like this next rule, all right? And then you'll see like a to the m minus that. So let me show you like an example of how you would solve a problem like this. And I don't know why, but I like the number 2. It's an easy number. So like, let's say I did 2 to the 5th power, okay? And I'm going to divide that by, say, 2, we'll do it to the 3rd power, okay? So one way to do that is just, let's apply this rule. So we're going to get 2 to the 5th, and the bases are the same, okay? So I can use this rule. I'm going to subtract 3 because that's the exponent in the bottom. And so like 5 minus 3 is 2. So that should be 2 squared. All right. Let me show you, let me try to give you a second way to make sense of this. I'm going to do one more, kind of like a longer way to help you understand it more intuitively. So like 2 to the 5th power is 2 times 2 times 2 times 2, 1, 2, 3, 4, 5, divided by 2 to the 3rd power, which is 2 times 2 times 2. And now you have like a bunch of numbers you're multiplying, and you can cancel things out. So this 2 cancels with that 2. This 2 cancels with that 2. This 2 cancels with that 2. And now you're just left with 2 times 2, or 2 squared, which is the 4. Okay. Does that one make sense?
Yeah.
Yes.
Now, question for you guys. Have you seen this in a previous math class? Is this mostly just like review right now?
Yeah.
Kind of.
Review?
Yes.
Okay, cool. So check it out. I think there's just one more rule or one more example that I do want to do. Oh, yeah. Okay, so check it out. I think I want to do 2 more examples with you guys, and then I'm just going to have you guys solve some problems. Let's say you have like 1 over 7 squared. Okay, you guys can still see that? Yeah. Well, let me take one step back. One step back. So I'm gonna do that problem in 1 second. What is let's say 10? What's 10 to the power 0? Can you just shout that out for me? What's 10 to the power 0?
1.
1. Good. What is 15 to the power 0?
1.
1. What is 100 to the power, or let's just say, what is 7 to the power 0?
1.
Good. So I just wanted to get you in the habit. Anything to the 0th power is the number 1, except for the number infinity, because the number infinity is not a real number. So if I were to write something like this, 1 over, make sure you guys can see that, 1 over, say, 7 squared, okay? One way to think of this as 1 over 7 squared, to help you understand, this would be like 7 to the 0 power, because like 7 to the 0 power is 1. So I can just rewrite that like this, like that, okay? And now we'll apply that rule, the one that, let me erase this here. You know, I said like a to the m power divided by a to the n power. That is, you know, this is basically the rule that we just did. But now this is a special case. We know that 7 to the 0 power is 1. So I can write this as 7 to the 0 minus 2. So 0 minus 2 is minus 2. Like that. All right, does that one make sense?
Yeah.
All right, one last problem, and then I'm just going to show you problems. I'm going to have you solve the problems. All right, so with that said, erase this. Let's go with 3. So 3, let's say, keep the number simple. Let's say 3 squared. And I'm going to divide that by 3 to the negative 7, okay? And so notice there's a negative on the bottom, okay? So I can now notice the bases are the same. All right, we have the same bases, and so we're just going to apply the rule. Here's my base, keep that, 2, and now I'm going to subtract, okay, a minus 7, because that's what our rule says that I keep erasing. So this rule thing here, can you guys see that? Yeah. The rule that I keep erasing, I'm just going to apply that to this problem. But the thing you have to be very careful about, use parentheses on this one. Whenever you see a negative number, a negative exponent in the numerator, this is the denominator. Make sure that you're subtracting a negative number. So a negative times a negative is what is a negative times a negative?
Positive.
A positive number, good. I'm gonna write that right. Okay, I'm gonna erase that one more time. So this now becomes 3 minus a negative 7 is plus 7. So this will be 3 to the 9th power. Can you guys see that okay?
Yeah.
Does this make sense? In my experience, this is the rule that becomes very tricky, okay? I'm going to show you one other way to think about this problem. So I'm going to try to show you a slightly different way to do the same problem so that you can check your work. So I'm just going to rewrite this as 3 squared. That's on the top. And then this number here in the bottom, I can write that, because this is 3 to the negative 7, I can write that as 1 divided by 3 to the 7th power, like that. And in a previous class, you might have heard that, or you might know that this is called an improper fraction. Right? Have you guys heard that term before? Improper fraction?
Yeah.
Yeah? Okay. And for some reason, and just so you, that number's hard to see. So that's to the 7th power. So like, you know, when we see an improper fraction, you need to like rationalize it. So like, if you wanted to do that, you would have to multiply by like, you know, it's like reciprocal. So 3 over 7 over 1, just like that. But if I do this to the bottom, I have to do it to the top. Okay. And then, so this cancels with that. And then you just get 3 squared times 3 to the 7th. Which again, you can just apply the other rule. So this would just be 3 to the 9th power. All right, so I just wanted to show you a few different ways to solve those problems. All right, so I'm going to go to screen share for a second. All right, so everyone should have that right now. Okay, so you should have that open. But what I'm going to do is like, I'm not going to have you, well, do you guys have a whiteboard at home? Yes or no?
No.
Oh.
No. Okay, that's totally fine. So check it out. I'm just going to put up a problem, and if you could just simplify it, and I'll give you guys about like 30 seconds per problem. I'm not going to do a stopwatch, but what I'll do is after you solve it, I'll just write the answer on the board. And if you need me to show you how to do it, I will. So yeah, go ahead and just like simplify that one. And this would be the simplified form right here, the k minus 3. All right, let's go to the next one. And if anyone needs any of these done out, please just stop me. Don't just wave, like kind of like yell out, do that out, please, because I can't see most of you. All right, so go ahead and do this one, please. All right, so if you did it, like you should get just the number 2. right? Because 2 to the fourth, so like, just in case, because this one's like 2. You should rewrite this as 2 to the fourth. You have the same bases, and it would just be -2 minus 1. So 4 minus 2 is 2, minus 1, it should just be 2. If I'm not good, if I'm explaining it too fast, please stop me. So go ahead and do that next one. So that one should just be 5 cubed. And if you guys need me to do any of these, please let me know. All right, go ahead and do the next one. That's a good one to do. The x to the -2. Go ahead and do that one. So does anyone need that one done out?
What is the answer? I can't really see what you wrote there.
Yeah, so I wrote x to the -5. Let me write that bigger just in case.
Okay, we can't see what you write. You're sharing screen, so we don't see the bar.
Oh, okay. Sorry. Let me. That makes sense. Sorry, I didn't realize how. Is that better?
Yeah, now we
X.
can see.
Okay, you can see that now. Right, so what I'll do is
Yeah, thank
I
you.
won't. You're welcome. I won't screen share. I'll just kind of go back and forth. If you guys could go to the next slide. It's the one that says rewrite as a power with base 2. That's just kind of like to try to get you to remember that base 2. You're going to do like 2, sorry, squared. But how about the next one? The next slide, it says, so rewrite using base of 2. The one that's 1/8, can you rewrite that as a base of 2? And there's actually 2 possible answers that you can get because this one wasn't super specific. So I think that was what, 1/8. So you could write that as 1 over, well, I'll give you guys a moment. What's 8 as a power of 2? 2 to the power, so if you have base 2, what could this be?
The power of 3, so
And if like you were doing like a test and like you weren't sure what, if like this was not a possible answer, you could also write this one as 2 to the power of -3, because sometimes when you simplify it, they want it, this is still a fraction, right? And sometimes like, on a test, they want to see this form. They want to see it in its most simplified form.
okay.
And if you could go on to the next one. So that should be, what should that be? What should 1 over
3
9
to
be?
the
There's,
negative 3.
go ahead, say it again.
3 to the negative 3.
Yeah, so like it could be like 3 squared, and then that would be like 3, not to the negative 3, but negative 2.
Sorry, negative 3.
And just like, yeah, I do that. I'll say things like that out loud all the time. Don't worry about it. Yeah, so it's 1 over 9. 9 is 3 squared. And then we can bring this up top and get 3 to the negative 2 power. Does anyone have a question on that? No?
No.
All right, so check out the, how about this next one? It says rewrite using base of 3, and they give you the number 1. So what would you rewrite that one? It says rewrite this number using as a base 3. How would you do that?
3 to the power of 0.
Very good. 3 to the 0 power. That's to just try to get you into the habit of thinking, realizing that this can be any base. It could literally be like 3, rewrite this as, write this as a, so like if I said rewrite this as a base of pi, well, I could just say pi to the 0 power. Okay, like you could have any base possible. There's another number that we're going to start talking about, the number e. So just like the number pi is like a really important number, which is about 3.14159 and so on. There's another constant in nature known as e, and we'll talk more about what that is. I think probably because of time, probably next class. But like e to the power 0, okay, is the number 1. All right, e is about just like pi is about 3.14. E is about 2.73, and really that's just an approximation. But we'll talk about those numbers later. All right, so the next slide. Okay, it says 9 times 3 to the p power. So see if you can do that. So I put a hint on the board if you're stuck. All right, so the next one. So we're going to do, I think we'll do 1, maybe 2 more. So if you could do the next one that says 27 times 3 to the d power. So if you could do 27 times 3 to the d power. You guys see that answer? Do you guys have any questions on that one? All right, let me just check one thing here. I'm going to go ahead and I'm going to share my screen with you again. All right, so went way too far. Okay, so we now have, so for homework, what I would like you to do, so homework. Okay, so I believe that this is slide number, oops. All right, so this is slide 17. And this is the one that has like 9a divided by, actually, maybe we should do that one. We should maybe do this one together. 3 to the 1 minus a. Let's do this one together. So let's do that one together. So let's call this, so for homework, I would like you to do, what was that, slide 18? Sorry, slide 18. Okay. And all the way to, there's one problem per slide, and it goes all the way to
36.
is it, slide, not 36, but slide 27. So from slide 18 to slide 27, okay. So that would be what, 9 problems?
Yes.
Yeah, so it's 9 problems. There is, but I would like to do this one together. Yeah, so this one will be the last one that we do. So hang on, let me find that slide again. Yeah, let's take a look at this one that says 9a. So first, let me just write that down. So everyone is clear on homework? Clear on homework?
Yeah.
So
Yeah.
9a divided by 3 to 1 minus a. So what I'd like to do, let's just do this one, and then we'll be done for today.
Could you please stop sharing your screen so that we can?
Oh, sorry. Thank you. Yep. Thank you. I'm gonna write this one up here so it's easier to see. So 9 to the a. I'm just rewriting this. 3, 1 minus a. Okay. And this one says simplify. So first, I just want to look at this. I'm going to rewrite this bottom term. So I'm going to rewrite this. So this is 9. I'm going to rewrite this a couple ways. 9 to the, was that a power? Sorry, it looks like a 9. So this, so 9 is 3 squared, right? Like that. And this bottom part is 3 minus a. So that's like that, divided by 3, sorry, that looks like a 9. 3 to the a power, right? Because, like our rule that says, like, let's say you have, going from this rule, a to the m power, this. Remember, if you see something that looks like this, they're trying to tell you to think of it like that. Okay. And so this is an a power. Now there's another rule that we could talk about here, like do we have time to talk about that? Yeah. Okay. So let me just do one side example. I'm going to do just a side example over here. So let's say that we have, this is just an example. Let's say I have 2 squared, and I'm going to do this times that to the, actually, you know what, let's switch those numbers because I don't want to have the same number as a base. Let's call this, we'll call this 2 to the 3rd power, and we're going to take this to, I want to use a different number. I don't want to use 2. I really don't want to. I don't want to use that number. Okay, hang on a second. Let's use. We'll just say to the 4th power, right? So one way to think of this. So this is like an example. This is 2 cubed. Can you guys see this? Okay. Sorry. So this number here, I just want to help you understand this part up here, is 2 cubed, 2 cubed, 2 cubed times 2 cubed. So like 4, we're doing it 4 times like that. So another way to think of that is if I were to apply my other rule, I could also say, can you guys see that number? This would be 2, they all have the same base, 3 plus 3 plus 3 plus 3. So this would be 6, what would that be? 3 to the 12th power? Or sorry, 2 to the 12th power. Okay. So the reason I'm trying to show you that is when you have something like this, like something in a set of parentheses, sorry, it's hard to hold my hands like parentheses. This just means you're going to multiply these two numbers out. 3 times 4, so this would be 3 times 4 would be 12. So 2 to the 12th power. Okay, so there's 2 ways to see it, and I'm just trying to help you understand this one up here. So when you see this, 3 squared, the whole thing to the a power, that's going to be 3 times 2a. Okay, like that. And I just want to show you one other thing. So like the other thing that I would do here, I'm just going to keep bringing this over. So 3, and then I'm going to look at the bottom one as one last example, then we'll be done. And that's looking like a 9. One way to help you understand this is let's just like do like the opposite, like let's undo this fraction. So I'm going to multiply the bottom by like the inverse. So I have to do that to the top. So I just want to get a proper fraction. So this cancels with this. That cancels with this. And now I have this thing up top. So I have, let's keep this in parentheses. 3, 2a. Can you guys see that still?
Yeah, we can see.
Times 3 to the a power. And then you still have this on the bottom, 3 to the 1st power. And I'm sorry, I'm kind of running out of room, so I'm just going to kind of bring this down here. And so now you have the same base on the top. You have 3, like this. So 3, 2a, you have the same base. So I'm going to apply that rule where I just add the exponents, like that. So this should now work. I'm sorry, I'm kind of doing this in like a circular way. But this would now be 2a plus a would be 3a, like that. And I'm just bringing this term along on the bottom. You guys see that? And then there's just one last step. So now I have this fraction, I can subtract this. So this would be 3a, this is on the bottom. All right, so I'd subtract it. And that should be our final answer would be right here. So I think that's,
Okay.
any questions on that?
Mm,
No?
no.
All right, so for homework, just finish out those slides. What is it? Slide 18 to slide was it
27.
slide 27, and that's homework. If you guys don't leave yet, I just got to do a quick little attendance thing. So I'm just taking a picture of names. That way it's easier to. All right, cool. All right, so you guys are free to go, and I'll see you guys later. All right, have a good day.
Have a nice day.
Bye. Bye.
Bye.
Bye. See you.
Bye.
Bye.